Eye tracking is a type of input that uses cameras and sensors to track your eye movement, and it has some pretty amazing benefits. You can have more expressive avatars to help with social interactions in XR, which gives you a much better ability to track those important nonverbal cues that you're used to picking up on in real life, such as where the eyes are actually looking instead of just an approximation based on your head movement. Eye tracking also allows you to use a more accurate foveated rendering system, which improves CPU performance while also helping reduce eye strain. And most importantly, it provides an accessible method of input for people with motor function impairments and allows people to stay hands-free when combined with voice commands. For those of you that come from a UX background, you may already be aware that eye tracking's been around for quite a while. The most prominent and popular company being Tobii, which has provided eye tracking tech for researchers for over 20 years. And then back in 2019, Tobii worked with HTC to provide eye tracking in their more expensive Vive Pro headset. You can also add on an eye tracking accessory to the Vive Focus 3. And of course, it comes built in with the HoloLens 2, the Apple Vision Pro, and the Quest Pro headsets. It's important to remember that eye tracking is a completely different type of input method than gaze targeting. Gaze targeting uses the center of your field of view and your head movement to interact with the environment, whereas eye tracking uses sensors and cameras to track your eye movement. Your input capabilities with eye tracking are much greater than they are with gaze targeting, but there are still limitations that we need to talk about. Eyeglasses can interfere with eye tracking, which is why headsets like the Apple Vision Pro don't allow room for eyeglasses and instead require you to use inserts. However, those lens inserts don't support everyone's needs, including mine. Uncontrollable eye movements or eye alignment issues interfere with eye tracking, making it unusable for a large number of people. And also, yet another little known fact that I discovered while researching headsets with actual humans: many people with eye alignment issues have trouble seeing 3D content, and also may only see partial content because XR requires both screens and both eyes. For example, one person I spoke with wasn't able to see a virtual object in 3D space. It wasn't that she was seeing a flat object, she couldn't see it at all. This doesn't happen with everyone, but one person is enough to make it worth thinking about because she's not the only person with that vision issue. And here's yet another little known fact. Twitching from astigmatism can also interfere with eye tracking interactions, or it can cause accidental misclicks if it happens in the middle of an uncontrollable eye twitch. That's actually a problem I have. If I'm staring at something intently, my eyes will suddenly twitch. And these issues are some of the main reasons eye tracking is not recommended as a primary input method for interfaces. Make it optional, or make it easy to add accessible input options for those who can't use eye tracking. Or better yet, figure out a way to make it a non-issue. You can't expect mass adoption when the masses can't even see what's in the headset. That said, let's talk about how to make the most of this input method. First of all, different headsets have different capabilities. So you're going to have to get familiar with the capabilities of your target headset, and you're going to have to think about how that's going to affect your experience. For example, eye tracking needs calibration. So if your headset requires you to go through eye calibration for each individual, that's going to affect the usability of a shared headset. Second, make sure you provide multiple options of input for your experience. Don't rely solely on eye tracking because, like I said before, not everyone can use it. You also want to make sure you reduce any visual distractions. Think about how often your eyes wander, or how often they jump to sudden motion in your periphery. If someone's in the middle of an interaction with their eyes, this could disrupt the interaction or cause accidental interactions. So think about what's going on in the virtual environment whenever you're wanting someone to interact with something using their eyes. And don't forget to test with your target audience. Pay attention to anything in the environment that might be unintentionally drawing their eyes away from where you want them to look. Remember, this is very important since they're using their eyes to interact. And as with any interaction on any platform, you want to make sure the target area is big enough for people to easily select an object or a UI element. The minimum size of that target area depends on the resolution of the device. For example, Apple Vision Pro requires their UI elements to have a margin of at least 16 points on all sides to give enough comfortable space. Your target device should give you guidelines on this, so check those out. Also, make sure to follow standard XR UX best practices for comfortable placement of interactable objects and UI elements, and make sure they're in the head comfort zones. I go more in depth on that in another video, so I'll include that in the resources. And keep important content within comfortable viewing distances to decrease the risk of eye strain. I'll also include my video about that in the resources, so check that out later. You can click on the screen right now to learn more about vision correction for XR headsets. I hope you enjoyed this video. I'll see you in the next one.